Good day, viewers. Welcome to Simplified Chemistry channel. And this is a channel where you learn a lot about chemistry. And I believe that today's topic will be of a great benefit to you. Today, we are going to be discussing about chemical bonding. Chemical bonding. So, join me as we teach. Chemical bonding. If you have been a regular student of this class, we've talked about many topics and we've discussed a lot about many things in chemistry. Chemical bonding is also an important aspect of chemistry which every student should learn. Chemical bonding involves the coming together of one or two elements to form a stable compound. So we define chemical bonding as the coming together, the combination of two or more elements to form a stable compound. The word stable compound here can be referred to as the elements trying to form an octet. The elements trying to form an octet or duplet. When I say octets, they want the outermost shell to have a stable configuration like that of helium. Having 8 electrons at the outermost shell. Helium, neon. So when we're talking about the duplets, we're talking about the helium here. Having 2. Helium. Then 8. Argon outside. Neon outside. Having 8 electrons. So octets, that example in case of neon, argon, and duplets like helium. So that's the main reasons for elements, atoms combining together to form a stable compound, to have an octet or a duplet structure. In order to attain this, we have different types of chemical bonding. We have different types of chemical bonding or chemical combination. We have different types of chemical bonding. So, types of chemical combination or bonding. Types of chemical combination or bonding. 1, we have electrovalent bonding. Which is also known as ionic. Number 2, we have covalent bonding. Which can also be further split into ordinary covalent, dative, or coordinate covalent bonding. Number 3, we have hydrogen bonding. Number 4, we have metallic bonding. Then we have the weak force of attraction, the Van der Waals force. So, we have electrovalent bonding or ionic bonding. We have covalent bonding, which can be split into ordinary covalent dative or coordinate covalent. We have hydrogen bonding, metallic bonding, and van der Waals force. For the sake of this class, we are going to start with these two. We are going to be starting with these two. Now, let's talk about the first one. Electrovalent bonding or combination, as it might be referred to in your textbook. What is electrovalent bonding? What is electrovalent bonding? What is electrovalent bonding? Electrovalent bonding is the bond that exists between a metal and non-metal. It involves the transfer of electron from a metal to a non-metal. I repeat, it's a bonding that exists between a metal and non-metal that involves the transfer of electron from the metal to the non-metal. In electrovalent bonding, there will be loss of electron from the metal and there will be gain of electron to the non-metal. As a result of this, it will lead to the formation of ion, which gives birth to the name ionic bonding. Because when the metal is losing the electron, it has a charge of plus. Then when the non-metal is gaining the electron, it has a charge of minus. As a result of this, electrovalent compounds will be ionic, number one. Number two, they will conduct electricity as a result of the charge. This transfer of electron and gaining of electron gave them their properties, which we are going to also be discussing in this class. We said electrovalent bonding involves transferring of electron from a metal to non-metal. So the metal will lose an electron or more to the non-metal. It will lose an electron or more to the non-metal. So electrovalent bonding involves the transferring of electron from a metal to non-metal. Let's see example. Example, e.g., let's see formation of sodium chloride. Formation of sodium chloride. Let's see formation of sodium chloride. Let's see formation of sodium chloride. Let's see formation of sodium chloride. Example, formation of sodium chloride. Let's see before the combination. Before combination, sodium atom and chlorine atom, which makes the sodium chloride. Number of protons in sodium is 11. Number of protons in chlorine is 17. The electronic configuration. The electronic configuration 281, 287. Now, let's see what will happen after combination. After combination, for sodium atom, don't forget, the proton remains unchanged. The proton number remains unchanged for both. But their electronic configuration, for sodium, it becomes 2,8. And for chlorine, it becomes 2,8,8. For this one, meaning it has lost 1 electron. Therefore, it becomes sodium ion. In this place, it gains 1 electron. It becomes chlorine ion. Let's see the grammatical representation of this formation. Sodium plus chlorine to give you sodium chloride. Sodium 281, 287 for chlorine. Let's represent the outermost shell. We have shell K and N. So for this purpose of this class, we are going to be representing only the shell N. So let's represent the 1 electron outside plus the chlorine shell K, N, and N. Let's talk about the outermost shell that is combining. So 7 using star symbol. 4, 5, 6, and 7. After combining, sodium will transfer this outermost electron to chlorine to give you a result of 2, 8. So shell K and L. 1, 2, 3, 4, 5, 6, 7, and 8. And chlorine also having 1, 2, 3, 4, 5, 6, 7, and 8. This is the electron gain. This is the electron gain. Electron gain. Electron gain. So this is a sodium ion and chlorine ion. At the end of the day, you will see they are both having an octet structure like that of the neon, the group 8 elements. So sodium having an octet, chlorine having an octet. So electrovalent bonding, once again, we said is the bonding that involves the what? This transferring of electron from a metal to a non-metal in order to attain a stable configuration. In order to attain a stable configuration, as a result of that, there will be formation of ions. Due to this process of transferring and gaining of electron, this gives the electrovalent compounds their properties, the ionic compounds their properties. It gave them their properties. Give them their properties. Give them their properties. Number 1, there will be formation of ions. There will be formation of ions. They are conductors. Electrovalent compounds are conductors, which means they are also an electrolyte. They are electrolytes. They are soluble in polar solvents. They are soluble in polar solvent and non-soluble in non-polar solvents. Non-polar solvents. So polar solvents, e.g. water, ethanol. That's why your common salt is soluble in water. And non-polar, e.g. kerosene, petrol, etc. etc. This gave them their properties. We also have the ionic compounds have high melting points. They have high melting points. They have high melting points. They have high melting points. I believe we understand what electrovalent combinations entails. Let me quickly recap. We said electrovalent combination or bonding involves the bonding between a metal and non-metal. It involves the transfer of electron from the metallic atom or element to the non-metallic counterparts. As the result of this, there will be gain of electron and loss of electron, which gives the electrovalent compounds their characteristics of high melting point and boiling point, their ability to conduct electricity, and the formation of ion. I believe with this you understand what we are discussing. In our next class, we are going to be discussing about the covalent bonds and other bonds. Thank you. Please don't forget to watch our videos, share, and click the like buttons. Thank you.